So we're now going to talk about part 2 of case study EX4. And this picks up where we left off with part 1 and shows a boatload more ways of being able to integrate streams with Project Reactor features. And it also shows how to do some other interesting things that we're going to talk about here in just a second. You can find this example once again in the EX4 project in my reactive Flux folder in my live lessons GitHub repository. So here we are back in this particular example. This is the EX4 example. And you can see that we've got a couple of different methods under test this time. Test fraction multiplication streams EX1 and test fraction multiplication streams EX2. So let's go ahead and take a look at both of those examples. And this first example shows once again how we can combine the Java Streams framework with the Project Reactor framework and the Java Common Fork Joint Pool in a slightly different way than we looked at earlier. So once again here, we're going to go ahead and use get MonoStream, and it's going to go ahead and generate the results. And we're going to end up here with a stream of monos. This is very much like what we had done before, where we use the streams framework to generate random big fractions up to a certain number, and we reduce and multiply them. And then what we're going to do is we're going to use the limit operation to only take S-max fractions of them. And then the last thing we're going to do here, sorry, let's keep going. And then what we're going to do is we're going to collect all those to a mono list. This again is exactly what we had done earlier, so I'm not going to go through it again. You could watch part 1 of the video if you need to see how the mono list collector works. And then the last thing we're going to do is we're going to convert this mono to a list of big fractions to a flux of big fractions. So what's really different from what we did before? Well, if you look at what we did before, we collected this to a mono to a list. And then we took that list, which was just a good old Java list, and we used FlatMap to sort and print the list. This time, what we're going to do is we're going to use a very interesting method called FlatMapIterable. And what FlatMapIterable does is it's going to take a mono to a list of something and convert it into a flux of something. And we're going to do this by using the identity function. And the identity function in this case is just going to end up creating a flux. So you'll see we have a flux here. And once we've got this flux, then what we're going to do is we're going to go ahead and sort and print the flux. So that's something we haven't done to this point. We've always been sorting and printing lists instead. So let's see how you can sort and print a flux. This is actually not unlike sorting and printing a stream in modern Java. So you can see what we do here is we take our flux and we're going to use the sort operator on the flux. The sort operator will sort the flux. We then print the intermediate values out. And the final thing that we do in this stream is after all the other computations are done, we display the results. So we're going to display the results after sorting the values and basically storing the intermediate operations here in the string buffer. And you can see the very last thing that we do is we return an empty mono, which is once again a flag to the async task barrier that everything's done. So that's how we're going to use this mechanism. This is kind of fun because it illustrates how you can convert from a mono to something, a mono to a list, to a flux automatically. And the last method we're going to look at in this example is test fraction multiplication stream EX2, which will show how to do all this stuff in yet another slightly different way. So you're getting a chance to see a bunch of different variations on a similar theme. So this example is going to take it's going to call the get MonoStream method. This is exactly as before, so I won't dwell on it at all. Make a bunch of random big fractions and reduce and multiply them in the Common Fork Joint Pool. And now we're going to use collect in order to collect to a flux. So remember, before we've been collecting into a list. That's what we did up here. We collected to a list, and then up here we also collected to a list. But down here, we're going to go ahead and collect to a flux. So let's go see how we collect to a flux. Well, as you might expect, we do that by using a flux collector. And the flux collector takes a stream of monos to objects of type T, generic types, of course, stores the intermediate values in a mutable result container, which is a list of monos to type T. And then finally, it'll return a flux to the elements of type T. So let's take a look at the various methods that are part of the collector implementation. So we have a supplier that stores this as an array list. We have an accumulator that adds each item to the list. We have a combiner that's going to add one list to another. And then finally, we're going to have the finisher. Now, the finisher here starts out very similar to what we did before with the monos list collector, but the flux collector is going to have a slight different finish. So we're going to go ahead and use the when operator to wait for all those monos to finish doing their computations in the background. We're going to use materialize, which basically says signal me when everything's done. And then what we're going to do is we're going to iterate through the list of monos and turn them into a flux. So there's actually a way of taking a list of monos and turning them into a flux instead of a list of monos. And then we're going to use the map method, which again will just convert the flux stream of monos to elements of type T into a mono to a flux of elements of type T. So that's what gets returned here. So we're going to get back essentially a flux of these results. So flatmapmany is going to end up returning a flux. Very, very, very interesting. Very, very cool. And you'll notice that we're using flatmapmany here rather than flatmap. So flatmap would return us a mono to a flux, but we don't want a mono to a flux. We want a flux. And so by using flatmapmany, that will essentially denest the inner element, which is the flux, and make that the actual return value. So we get a flux back from this thing. And so then we take the flux that comes back here, and we use the sort and print flux operation to basically take the flux of big fractions and sort it like we did before, and then display it when it's all done. So just to take a quick look at the results here, you can see we have test fraction multiplication stream Ex1, which prints these sorted results. And then we also have test fraction multiplication streams Ex2, which prints a different set of results because things were generated randomly. So that's where the results come from. So that's the end of this part of the discussion, rounding out the case study Ex4 second part.